The following systems consist of two functions. While one or both of the equations may be nonlinear, the system can still be involved in the system can still be solved by finding points of intersection on a graphing calculator. Does that make sense? Have we done systems of equations before? Like that? Yeah, we did a whole big project with QR codes out in the hall. You remember that? Systems of equations. And what is a solution to a system of equations? Where they intersect, right? Where they cross, that's the solution, right? So what makes it different if it's called a nonlinear equation? They're still going to cross, but they're not going to be lines, right? There could be one of them could be a line for sure, but these are all nonlinear equations or nonlinear systems, okay? So that the whole system is not necessarily a line or multiple lines, right? What are these? Parabolas, right? They're squared, so each of them are parabolas. What about this? This is a parabola, this is a line, right? So we're trying to find where they intersect, where we cross. Not we. I don't know why I said we as if I was a line or a parabola, okay? I think it would be more like a circle anyways, so, or an oval. What? Thank you. Okay, so let's do number one together. Can we do that? So tell me how we're going to do this. Okay, so we should take out our calculator first, and the next step should be turn it on. Excellent. What? Here, come get this one. So start a new document. Mine's thinking. We're going to start a new document that is a graph. So what am I going to put in f of 1? First equation, okay. X squared plus 4x plus 5. Is that what I expected the shape to look like? Yes. Okay, I knew it would be a parabola that opened up because my x squared term is positive, exactly. Okay. Now I need to hit tab and put in my second equation, right? X squared, good, minus 2x minus 6. Okay, so knowing what we know about parabolas, which is a lot, is this side right here going to come back this way to cross this again? Or is this side going to go out this way to cross this right here? It won't, will it? This is going to keep going up and up and up that way. This is going to keep going up and up and up that way. So is there an intersection I can't see over here? No. What about over here? Is there an intersection over here that I can't see? No. So where's the only intersection? Right there where I can see it, right? So first of all, I need to sketch this graph. Now, when we did quadratics, when we worked on parabolas the first time, how specific were we when we graphed? We were super specific, right? We found the vertex, we went over one, up one, if there was a multiplier to find the exact place where the parabola lived, right? We did that already, right? So when it's asking for a sketch, I'm asking for a general sketch that looks like what's in the calculator. Do I want you to get some things like really, really good? Yeah. Do I need to know that my red parabola probably crosses at -6? 1, 2, 3, 4, 5, 6. I need to know that it probably crosses at 6 and it goes down a little bit more than that. Where does it cross the x-axis? 1, 2, in between 1 and 2. So right there. And 1, 2, 3, in between 3 and 4. So right there. So it probably looks something like, not that. I can do better than that. Oh, it goes down further, doesn't it? 1, 2, 3, 4, 5, 6. Okay, so like that. Is that pretty good? Okay, what about this one? My blue one. Well, it doesn't cross x-axis, so I can't help with that. But I do know it crosses at 5 over here, right? 1, 2, 3, 4, 5. So maybe like that-ish. Okay? Now I'm trying not to embarrass anyone by being too perfect with my art. The point fixes it, yeah. The point is, where is the solution I'm looking for? Right here. That's what I'm looking for. How am I going to find that point of intersection? Menu. Intersection. Right? Menu, analyze, and then intersection. So if I choose intersection, again it says lower bound. So I want that on the left side of the intersection and click the middle button. And then it says upper bound. I want that on the right side of the intersection and click the middle button. So what mine says is negative 1.83, comma 1.03. Is that what you got as well? Okay. So what if it actually did cross 2 times? Could I go menu, analyze, intersect, and then put this on, maybe let's pretend that it crosses right here. You know and I know that it doesn't, we're pretending. Okay? If I could click the lower bound, can I just bring the upper bound all the way over here to this side to see both? It will not do that. You're going to have to do them one at a time. Okay? One will show up, but not both. I think the calculator just gets confused because it's just a machine, right? Okay, so it'll do one, but not both. So you need to do one at a time. Do this intersection. Obviously, we know that that one's there already. And then if there was one over here, you would start again, put the lower bound here or the upper bound here to find this one. Does that make sense? Okay. So like I said, go ahead and circle number 2 and 3 and 6. On the next page, would you please circle number 10? Number 10. Yes, ma'am. Okay. So those you're all going to solve with the graphing, with the graphing calculator by using menu, analyze, intersection. Okay. All of those you're going to solve that way. Notice how it says solutions. Will there always be solutions? No, I just proved that, right? There's only one here. But if there is multiple solutions, you've got to find all of them. Okay? The second half of the worksheet deals with solving algebraically using the substitution method. Do you remember the substitution method? Oh, hey, guess what? I remember it. Is it okay if I show you an example of it? Then let's talk about number 12, please. Okay? So in number 12, you okay? Okay, so in number 12, what we're talking about is solving with substitution. So, I mean, I don't want to say obviously because I don't want anyone to be offended by that or hurt your feelings or like make you cry. But we have to substitute something in, right? To me, that seems obvious if it's talking about substitution. Does that seem obvious to you? Okay, so no one's crying, so that's good. We can go on. Okay? Guys, if y equals this and y equals this, what should also be true? They should be equal to each other, right? So technically what we're doing is we're taking this and substituting it into y. Or taking this and substituting it in for y. But in reality, like I said, technically we are using substitution, but we're also using our brain. And knowing that if y equals this and y equals this, then they should equal each other, right? So 2x plus 1 equals x squared plus 3x minus 5. Did you have a question? You good? Yeah. Or were you just waving at me? Oh, waving? Okay. Hello. What should we do now? It's a quadratic, so we want to get it set equal to 0. That's exactly right, okay? So how about if we subtract 2x from both sides? And how about if we subtract 1 from both sides? Will that work? So 0 equals x squared plus x minus 6. Everybody okay with that? We can factor, right? For sure we could use quadratic formula, right? Because it's a quadratic. But this one, we see right away that we can factor. So let's factor it. What two numbers multiply to be negative 6 and add to be positive 1? How about the other way? Negative 2 and positive 3, right? Because they multiply together to be negative 6, but when we add them together, we need it to be positive 1, so I need 3 to be the positive value. Okay? So when I solve this, I have x minus 2 equals 0 and x plus 3 equals 0. Add 2, x equals 2, subtract 3, x equals negative 3. Okay, so that's a good question. So first of all, let me make sure the people that are listening heard what happened. Okay, you said now we have to plug them in to see which one works. And what did you say? So why would we have two x values as solutions? Because we have 2 points of intersection. That's exactly right. Okay, so we don't put this, like don't write this down. Okay, I'm going to write it down to make sure you know what I'm talking about, but don't write it down because it's wrong. Okay, don't do this and say that's the point of intersection. Because both of these are what? X's. So I know I have 2 points of intersection that are going to look like this. Right? That's what the answer, not this. This is, no, no, no. Okay? This is what my 2 points of intersection look like. What do I need to find? Yeah, the y value. So how am I going to find the y values? Substitution, right? So if I take 2 first, should I plug it into the top or should I plug it into the bottom? So that's the best question. Doesn't matter. No, it does not, because they should both equal the same. Why would you choose the bottom? So much easier, right? So much easier. Okay? So what's 2 times 2? Excellent. Plus 1. So the y, oh my gosh, I didn't even write anything down for that. Yeah. What about negative 3? What's 2 times negative 3? Negative 6 plus 1? Negative 5. Now, can I show you something real quick that you're not required to do, but I just want to prove something for you? No? Okay. Oh, okay, okay. If x is 2, 2 squared, 4. 3 times 2, 6. So we have 4 plus 6 is 10 minus 5. Look. You do get the same thing no matter which equation you choose to plug it into. Okay? Do you have any questions about substitution? No? Oh, okay, ask me. Oh, that's a really good question. How about number 13? Because that's my favorite number. How about number 14? How about number 16 and 17? Okay, 16 and 17. Any questions on this? Okay, if you have them, you should ask, right? Yeah, absolutely. Okay, any questions? Oh wait, I already said that.